So today we will do crystal field stabilizing energy. It will be calculated, and we will do it for first of all for octahedral complexes. So this is number of metal ions, number of d electrons in metal ions, distribution of electrons. Here we have assumed that the complex formed is a high spin complex, and this is crystal field stabilizing energy. So this depicts number of electrons. So this is d1. Here you can see T2g Eg orbital, and all the complexes are high spin complexes. So very important thing to note is that where delta naught is less than, that crystal field stabilizing energy is less than the pairing energy. P is the pairing energy, which is also that is delta naught is less than the energy of electrostatic repulsions among d electrons. In this case, maximum number of electrons remain unpaired, and we get high spin complex, or they are also called as weak field complexes, high spin complex or weak field complexes. So here I have calculated crystal field stabilizing energy for high spin complexes. These are T2g orbitals, this is Eg orbital, this is an octahedral complex, and these are the number of electrons, unpaired electron when there is 1. So 0 minus 4, it is 4d3. When 2, so 2 into minus 4, 8, 0 minus 8, that 0 minus 8 plus 8, and so on. I hope you can calculate, because this is just a recapitulation. You have also done it in your lower class. One more thing to note, yes, from here, from D4, since this is a high spin complex, they are not being paired. Electrons जो हैं यहाँ पे वो pair नहीं हो रहे हैं, क्योंकि these are high spin complexes. अगर ये low spin complex होते, strong field complex होते, तो I would have paired them. Then the energy would have been different, crystal field stabilizing energy. So this is for D5, D6. Here you have to pair them, there is no other way out. So from D6 the pairing that will start, and till D10 you can do it, and we can calculate the crystal field stabilizing energy. Now for in case of low spin complexes, till D3 it will remain same, because there is no requirement of pairing till D3. Now if this delta naught is greater than P, that crystal field stabilizing energy is greater than the pairing energy, the complex has less unpaired electrons and is called low spin complex or strong field complex. Means here the pairing will occur. So pairing will start from D4. So for D4 we have, you can see here, the energy will be 16 dq, and here Eg will be empty. Similarly D5, pairing will be given preference over single filling of the orbitals in case of in case of low spin complexes, that you have to remember. Similarly for D6, and from D7 the pairing will start, because there is obviously no way out, so the pairing will start, and till D10 it will go on. Then we have crystal field splitting energy in tetrahedral complexes. Tetrahedral complexes have reverse splitting as compared to octahedral complexes. Octahedral complexes से reverse होती है splitting tetrahedral complexes में, and coordination number is 4, and the 3 d orbitals dxy, dyz and dxz are in the direction in which the ligands are approaching. So these 3 orbitals dxy, dyz and dxz, they are in the direction of the ligands. So what will happen? The repulsions, they will increase, and their energy will be more. While the dx square minus y square and dz square, these 2 orbitals, they lie in between the ligands. So what will happen here, since they are present in between the ligands. So what will happen here? The repulsions, they will be less. Repulsion between the d electrons and the ligands, they will be less. So their energy will decrease here. So this kind of splitting is observed in tetrahedral complexes. You can see state 1, 2 more need, I will form, this is 2, 5d electrons. So this is state 1, degenerate d orbitals. State 2, when the charge is uniformly distributed, and this is the third state where T2 orbitals dxy, dyz, dzx, they have more energy. So they are in the, they have more energy. And this E orbitals dx square minus y square and dz square, it has less energy because they lie in between the axes on which the ligands are approaching, and they are in the direction of axis in which the ligands are approaching. So repulsions इनमें ज़्यादा होंगी और इनमें कम होगी, तो इनकी एनर्जी ज़्यादा होगी, इनकी एनर्जी यहाँ पे कम होगी. Total energy will remain same 10 dq. This order will be reversed as compared to that of tetrahedral. So delta T, that is minus 4 by 9 times delta naught, delta O. This is delta O is means octahedral. So delta T is minus 4 by 9 times of delta octahedral. Crystal field energy of tetrahedral complexes is minus 4 by 9 times of octahedral complexes. Crystal field stabilizing energy of octahedral complexes, and minus sign denotes that order of splitting in tetrahedral complexes is reversed. It is opposite of octahedral complexes. Then what is the trend in tetrahedral complexes? So no tetrahedral complex with low spin configuration has been formed. This is due to the fact that crystal field stabilizing energy in tetrahedral field is less and is comparatively small and is always less than the pairing energy. So CFSE is always less than the pairing energy. So what will happen? Pairing does not occur and complexes are high spin complexes. So in case of tetrahedral complexes, the complexes formed are high spin complexes. So pairing will not be there, pairing will be less. It is not that it won't be, जहाँ पे कोई और there won't be any way out, वहाँ तो pairing होगी ही. जहाँ पे सब ऑर्बिटल सिंगली फिल्ड हो गए होंगे, so then the pairing will occur, but first each and every orbital will be singly filled. So this you can see in D4, and obviously 4dq, that is the crystal field stabilizing energy, and so on. And I have only calculated for D4. You can calculate it for others, keeping in mind that this is a high spin complex, and this is how metal ligand that is approached by the metal ion that is approached by the ligands in a tetrahedral complex. These are the 4 ligands. So what will happen? DXZ, DYZ, their direction is, you can see they are approaching in between the in the direction of the DXZ, DYZ, YZ, DZX axis, and DZ square is along this direction, and DX square minus dy square जो इस डायरेक्शन में है. सो दे आर इन बिटवीन द, इन लिगेंड्स के बीच में आएंगे. जैसे dz है, ये भी लिगेंड के बीच में है. dx स्क्वायर माइनस dy स्क्वायर जो है वो भी लिगेंड के बीच में आएगा ऑर्बिटल जो है. तो क्या है, वो कम रिपल्शन फेस करेंगे, वाइल dxz इस डायरेक्शन में होगा ऐसे. dxz का एक लोब, तो अक्रॉस that will be in that direction in which the ligand is approaching. dxz, then dyz, dyz it will be in this direction like this. yz यहाँ पे होगा, and dxy will be in this direction. So ये जो आपके 3 ऑर्बिटल्स हैं dxy, dyz एंड dzx, दे विल फील मोर रिपल्शंस, तो इनकी एनर्जी हाई हो जाती है इसमें. सो दिस इज ऑल अबाउट द टेट्राहेड्रल एंड octahedral complexes. Thank you.